The oceans of the world have always been an important source of food and other materials for human society. Without any assistance from man, the seas maintain an abundance of life. Man's ever-increasing need for the products of the seas is the basis of many industries, the most important of which is fishing. Trawl gears have been used by fishermen for a great many years and have developed from simple beginnings into the complex equipment we now use. Scientists at the Marine Laboratory of the Department of Agriculture and Fisheries for Scotland are engaged in a research programme aimed at a better understanding of how fishing gears operate in practice. Knowledge gained from this kind of work enables new gears to be designed with which particular fishing operations can be carried out with greater efficiency. In other words, the aim is to reduce the cost to the fisherman per tonne of fish caught. Before a full theoretical analysis of a gear can be carried out, accurate measurements must be made under actual trawling conditions. The department's scientists carry out such measurements on board the research vessels, the largest of which is the FRS Explorer. The Explorer is fitted for both port and starboard side trawling. Thus, two gears can be tested and compared simultaneously on the same trip. Electronic instruments have been developed to measure tensions, distances, and many other parameters, both on the gear itself and on the ship. Here we see some of these instruments being taken from the laboratory to the ship prior to sailing. On this particular cruise, a large mid-water trawl will be worked on the port side of Explorer, while a high headline bottom trawl will be used on the starboard side. Both these experimental gears have been made to new designs, which are intended for industrial fishing work. We shall now go to sea with Explorer and see how this work is carried out under full-scale trawling conditions. The chief scientist and the fishing mate are discussing the most suitable ground on which to try out the bottom trawl. The value of the instruments attached to the fishing gear is much more than the cost of the gear alone, and so the test area is carefully selected to minimize the risk of damage to the equipment. There is much work to be done before the trawl can be shot. While the gear is rigged on deck, the instruments which will tell us something about how it is behaving in action are made ready in the ship's laboratory. This diagram shows some of the instruments as they will be rigged on the gear. A number of tension measuring instruments, called load cells, are used to measure the strain in various wires. Load cells are attached in front of the otterboards and also to each side of the headline and ground rope. The distance between the otterboards is measured by spread meter units attached to the warps. These operate in a similar manner to an echo sounder, as the distance between them is determined by timing acoustic pulses transmitted from one unit to the other. A similar technique is used to measure the width of the net mouth using transducer units attached to the wing ends. In this case, however, there is a cable connection between the transducer units and a central recording case on the headline. It is also important to know the vertical opening height of the net. This is done by measuring the hydrostatic pressure in hydraulic hose connecting two heads to a recording unit on the ground rope, One head is at the centre of the headline and another is at the wing end, so the heights of these 2 points can be determined. Finally, a camera unit is attached to the square, which takes photographs of any fish which are in the mouth of the net. One of the load cells is now prepared for use. When tension is applied to the load cell by pulling on wires attached to the lugs at the ends of the cell case, this causes a proportional movement of a stylus across a paper chart. The chart is clipped onto the drum, which is fitted to the load cell. The drum rotates slowly once the load cell is switched on, and the stylus is heated by a battery in the cell case, so that it produces a clear record on the paper corresponding to the tension applied to the load cell. The electronic subunits which control the measurement of otterboard spread are now loaded into one of the Mark II spread meter units. All the underwater instruments which are used on these tests are self-contained and are powered by internal batteries. This chart is fitted into the headline height manometer. Battery power must be conserved, and so the instruments are not switched on until shortly before the gear is shot away. This load cell is started by inserting a starter screw into a socket on the cell case. This activates a switch which sets the load cell mechanism in motion. The bridge is now informed that all systems are go, and shooting the gear away can begin. The instruments used on the gear are ruggedly built to withstand vibration and mechanical shock. Nevertheless, a fully instrumented fishing gear requires careful and skillful shooting to ensure the proper operation of the instruments. The bottom trawl uses curved otter boards, which are more efficient spreading devices than the more conventional flat ones. Another feature of this gear is the double bridle system. Each bridle is connected to a separate Kelly's eye and backstrap set on the otter board. Once the otter boards are in the water and some warp has been paid out, the Mark II spread meters are attached to the warps. When the spread meters are seen to be riding well in the water, the rest of the warp is paid out, and finally the gear is blocked up. The job's not yet finished, however. More instruments must be set up on the ship. The scientist needs to know what's happening on the surface as well as underwater. A tension meter is attached to each of the warps forward of the towing block. These meters operate by bending the warp slightly as it passes between the 3 wheels on the meter. The resultant strain on the center wheel is turned into an electrical signal, which is a measure of the tension in the warp. Next, an instrument is fitted onto the warps after the towing block to measure the angle between the 2 warps, and also the angle they make with the horizontal. Cables running from these instruments to one of the ship's laboratories are connected to a number of paper chart recorders. Information on warp angles and tensions is thus continuously available to the operator, who can tell from the recordings whether the gear is behaving as it should. The performance of the ship itself is also monitored throughout the hull. Continuous recordings are made of water speed, engine revs and propeller thrust. This information will tell us the ship characteristics which are best suited to a particular trawl. Down in the engine room, the propeller thrust meter is primed with hydraulic fluid. An echo sounder watch is maintained during the haul. As well as recording the depth of water, fish traces can later be compared with the catch. Fish are also detected on an oscilloscope, which is linked to the echo sounder equipment. After trawling for about 90 minutes, it's time to haul in. The scientists wait anxiously not only to see what the catch is, but also to see if there is a good crop of data in the instruments. The Mark II spread meters are the first instruments to come up. Once the spread meters are removed, the outer boards can be taken up and chained. Next, the bridles are winched in. The cod end floats. Some hungry gannets are there too. Let's hope there's some fish left by the time the gear is taken aboard. The catch is landed on the deck for sorting by species. Often rare or unusual fish are found, and these are preserved and taken back to the marine laboratory for examination. Now that all the gear is aboard, the instruments can be detached and taken to the ship's laboratory for processing. The headline height manometer is opened for the removal of the chart and battery. In the laboratory, the load cells are opened up. This one has produced a first-class recording. The paper is carefully marked with a hull number and other data for future reference. The camera is taken out of its case so that the film can be removed. Some film is developed on the ship, but most of it is kept for processing ashore. The cruise programme now calls for a test using the large mid-water trawl on the port side. The bottom trawl has therefore been stripped of its instruments, which are now rigged onto the mid-water trawl. The opening height of this trawl is so large that it exceeds the range of a single manometer. Instead, two manometers are used on the net, one to measure the lower half and a second to measure the top half. Another addition to the instrument set is a depth meter, which is fastened to the center of the headline. This continuously transmits acoustic signals which are picked up at the ship, and from these signals, the depth of the net can be determined. Using this information, the trawl can be maneuvered to the depth where fish are most likely to be found. The instruments are now switched on. The last load cell is started just as the cod end is going over the side. Working with a side trawler, it takes a long time to shoot and haul a fully instrumented gear as large as this. but in commercial practice, of course, such a gear would be fished from a stern trawler. Again, a double bridle system is used, connected to the large Super Crew waterboard by a single set of backstraws. With the boards away, the warp is paid out and the gear blocked up. Throughout the haul, the fishing depth of the gear is varied from time to time, either by changing the warp length or the ship's speed. This is done to find out whether the net can be made to intercept fish shoals which might be detected on the ship's echo sounder. Readings of the depth are taken from this indicator in the ship's laboratory, which receives acoustic signals from the depth meter on the net headline. When these tests are complete, hauling can begin. The instruments are taken off the warps before the gear is knocked out. And so another test has been completed. The gear will be taken aboard and the instruments taken to the ship's laboratory for collection of the haul records. Once all the results of the tests are available, they are examined so that the performance of the gears can be analysed. Painstaking effort is required to extract the maximum amount of information from the tests. The questions to be answered are endless. Has the gear been fishing evenly? How do the port side tensions compare with the starboard readings? Is there enough flotation on the headline, or is there too much? The work which we have seen shows what can be achieved by the fisherman and the scientist when they combine their skills. The work is hard, but it is rewarding because it is concerned with new means of increasing the productivity of the sea. Most of the time at sea is used to get the basic information which is needed, and so much of the final analysis work must await the return to shore. High-speed computers are being used to correlate the experimental data and to produce the most comprehensive results possible. But the aid of computers for this work is not confined to the laboratory ashore. New developments and techniques are even now being pursued, which will allow the computer to be used at sea, analysing information coming from the trawl even as the ship is towing. The knowledge gained from these experiments will provide a better understanding of the trawl gear in action, to the benefit of both scientists and fishermen.